3? Okay, give me 1 second here for chapter 2, and I'll be done. I'll make this one fast. Sure. I'll put it on YouTube. Hang on. I'm not. If you guys want to go, you can go. But I got one more chapter. But you can watch it or not. Okay, I think here we go. Here we go. Okay. You guys ready? Try to make this fast. This I can't find the PowerPoint. This is the PDF of it, but I think it'll work. So, orbitals. Talk about orbitals. What's an orbital? Right, it's that pathway for electrons. What I want you to know is this for orbitals. Getting a filled orbital is the whole point to it all. Right? How an atom reacts is how it can get that orbital filled. Right? That's the point. Valence electrons, those are the electrons on the outside. Point here is what? The electrons on the outside are what makes an atom react the way it does chemically. That's the take-home point. The electrons on the outside shell are what control how an atom reacts chemically. Does it want to lose an electron? Does it want to share an electron? If it shares it, it does something. If it loses or gains it, it does something else. Again, what can it do? It can give them up, it can take them on, or it can share them. 3 choices. We talked about ionic bonds. Just know the definition. What is an ionic bond? Positive, negative, combined. That interaction is ionic bond. More important one is covalent bonds. That's the one that we're made up of, right? Our atoms are connected with covalent bonds. We have nonpolar, weakly polar, and polar covalent bonds. And all it is just from a sharing of electrons. Just know the definitions. Chemical reactions. You know what is a chemical reaction, right? You got reactants, you got products. Things are either going to combine or separate. Chemical reactions are exergonic or endergonic. I think that's pretty self-explanatory. Exergonic, there's a net release of energy. Endergonic, there's going to be a net input of energy. Not the same as exothermic and endothermic, but they're somewhat related. Water, kind of an important molecule, right? What's the thing with water? It's a universal solvent. It has a positive region and it has a partial negative and 2 partial positive regions. And if you go back and look at the electrolyte slide, you'll see it actually where those regions can surround charged particles. We got 5 minutes left, so I'm just going to move to the organic part. Okay, so we said what? 4. You have to know the 4 macromolecules, right? Okay, you should know carbohydrates. What makes up carbohydrates? Carbon, hydrogen, and oxygen. 1, 2, 1. 1 carbon, 2 hydrogens, 1 oxygen approximately. Why is that important? That oxygen is going to make carbohydrates very polar. Makes it polar. What do you see? It goes into solution in water. No, these are examples of polysaccharides: glycogen, starch, and cellulose. More important for us is glycogen. We're going to store glucose in a long chain called glycogen. Okay, come with lipids. We're missing a lot of oxygens here, aren't we? What does that mean? That means lipids are non-polar. That's really important when we talk about the phospholipid bilayer membrane. Okay, so fatty acids are non-polar. Have an idea of the structure. You don't need to know that's palmaric acid, but if I had a picture of that, I want you to know that's a fatty acid. There's a picture of that on the test, and I said 1, 2, 3, 4, bang, fatty acid. Have an idea of what these molecules look like and be able to identify them on a test. I'm not asking for specific examples. I just want you to be able to say that's a lipid, that's a triglyceride, that's a carbohydrate. Okay, phospholipids. Just an example of them. Steroids, another lipid. Okay. Proteins, have an idea of what is a protein? It's just a polymer of amino acids. Have an idea of the structure of an amino acid. We got an amino group, that alpha carbon, and a carboxylic acid group, and an R group, which gives it variability. Peptides are connected with a peptide bond. Know the peptide bond. Okay. Have an idea of the structures of protein: primary, secondary, tertiary, and quaternary. Remembering quaternary is kind of an optional structure. Not all proteins are going to have it. Also note what? That secondary and tertiary are a function of the primary. You change primary sequence, and you very will likely change the secondary and tertiary sequence. I think I gave you an example of cystic fibrosis with that. Right? You change an amino acid, you change the whole structure, or possibly change the whole structure. Not every time, but you run that risk. And what a nucleic acid is. And if I show you this picture right here, that's a nucleic acid. If you saw this picture on a test, although there is carbohydrates on there, you should be able to say, well, there is a carbohydrate here, it's ribose, but the sum total of that tells me that's a nucleic acid. And find the last one here. Okay, here we go. I believe that was the only thing on that chapter. So then, you just want to call it there? Okay, I'm out of time. I'm at 2:45. So I'll see you guys next time. 1, 2, and 3.